For the kind of inspection work we do, consumer scanners just aren't accurate enough, and metrology equipment is usually out of budget.
With large part scans, things can get messy fast. The alignment's off, and that kind of delay can cost you the customer.
Traditional measurements already takes too long, and some scans just don't stay true to the real part.
And that's where things start to change. VoxMeta has spent over 10 years in industrial scanning. We know what precision means when real work depends on it. So we built H1 Pro, an all-scenario 3D scanner grounded in industrial-grade precision. Made for real users and real workflows. Built for precision and you.
I work with molds almost every day, so accuracy is really, really important. If the scan data isn't stable, we end up checking the same part again and again. And once rework starts showing up, it slows down everything after that. But with the H1 Pro, the part of this job just got a lot easier. I can scan the whole mold, see the data build right away, and move straight into comparison. What I like about the H1 Pro is that it brings industrial metrology level precision into something we can usually use every day. You're getting up to 0.015 millimeter accuracy, plus 0.015 millimeters and 0.03 millimeters per meter volumetric accuracy. And the data stays stable.
An aerospace-grade aluminum body keeps H1 Pro rigid and stable. An industrial-grade camera system delivers clear, low-noise imaging with consistent precision. Industrial aviation connectors, gigabit Ethernet transmission, Wi-Fi, and Bluetooth work together to keep every connection secure and transfer stable. Because in inspection, everything starts with data you can trust.
It's not complicated to use, and the pricing is much more reasonable for a team like ours. We can scan the whole mold, we can compare it fast, and we can move into inspection without all the usual issues. This means faster spot checks, it means less rework, no more staying late, and a smoother handoff across the whole team. It saves time and it saves money and it keeps the line moving. And honestly, it's just really, really practical.
At the shop, we scan large parts all the time. Bumpers, lips, side skirts, and even the full section of a car. And once the cable gets in the way or loop closure error, the whole job just gets messy fast. You lose time readjusting the equipment and scanning again. In this business, that can cost you the customer. Once I started using H1 Pro, the whole thing just felt a lot more under control, especially on larger jobs. It's a wireless handheld scanner, so I'm not dealing with cables all the time, and I'm not worrying about the battery life either.
With 120 frames per second and up to 4,400,000 points per second, the whole scanning process feels a lot faster.
Honestly, it's probably twice as efficient for the kind of work we do. And with scale bars, we can now scan large parts up to 5 cubic meters, with the volumetric accuracy now up to 0.015 millimeters and 0.02 millimeters per meter. So even the alignment stays precise even on bigger jobs. And that means one device handles most of the automotive customization work we do here without all the extra spending. So we spend a lot less time on measurement and test fitting now. And honestly, it just makes everything easier and more efficient.
When I'm working on custom modifications, reproducing old parts, precision and efficiency are always the hardest part. With consumer-grade scanners, the data often isn't accurate enough, and sometimes the scan gets cleaned up automatically. It looks better, but is no longer true to the part. But with the H1 Pro, I can finally capture the part the way it really is. Thanks to the versatility of Blue Laser, it handles different materials really well, which matters a lot in my work. What I like most is how true the scan stays to the real object. It doesn't try to smooth things over or improve the result. It just stays faithful to the part. So I'm not wasting time reworking the scan or second-guessing the data. And honestly, that just makes the whole process feel a lot more solid.
Different workflows lead to the same core, steady metrology-level accuracy with fully accountable measurement data. That's the thinking behind H1 Pro, and it's how VoxMeta approaches every tool we build. VoxMeta H1 Pro metrology-grade 3D scanner. True specs meet true value.
Good morning and welcome everybody in our live stream. I'm your host Farah from VoxMeta team, and I welcome you back in our next live session. I'm very excited today to showcase you our H1 Pro's performance. We have prepared some very interesting models to you to show you how our H1 Pro delivers the accuracy and the performance with these models. So you might ask, why do I have two H1 Pros in my hand? And you can see there is some difference on this one. So this is for the sake of comparison. So far we've been using the prototype H1 Pro that you can see on my left hand. This one, we've been using this one for a long time already. And today finally I want to show you the final product. So this one is the final product of H1 Pro on my right hand. So let's go do a little comparison between these two so you have an idea what the final product will look like. So of course we have only the external difference between them. Internal hardware is the same. So you can see there is the main difference is the grip, the lever, the handheld position is little different. We have a bulge in our final product that makes the grip much more stable and safer, right? So in our prototype we don't have this function. And also you can pay attention to the camera lens. Around camera lens on prototype we have 3 blue lasers when we have 6 blue lasers in each cameras on the final product. So this is an improvement again. And also you can see the texture on the laser here, and we don't have texture here. This is a reflective texture here. And also you can see the cooling fan is little different. This was the prototype and this is the final product. And that pretty much everything that you need to know about the final product. Now that we talked about it, let's move on to first initial configuration of the H1 Pro when you receive the product, right? So let's go put back our prototype back in the box and take out the USB flash drive. Why do we have a USB flash drive? For what purposes? Well, because you need this one to import the first one-time configuration files into your VoxMeta program, right? So here we have our program, and by the way, in today's session of live stream we're gonna demonstrate the wireless mode of H1 Pro. Only solely the wireless mode, no other modes. So let's turn on our device. We already have lithium batteries charged inside, so they are ready to work. Well, if you know to our live stream, you might not know that this one, the H1 Pro, delivers true wireless mode thanks to Wi-Fi 6 and Bluetooth, a gigabit wireless transmission. The connection is very stable, so we can connect our laptop Wi-Fi first to the 3D scanners Wi-Fi. Here you can see 009. That's the 4 final digits of our H1 Pro, and here you can write the password is Vision 3D by default. So we connect to the Wi-Fi. Let me take the mouse for convenience. All right, I hope you guys can see everything on the screen. So when you first open the program and connect the USB flash drive to your PC, you will have this auto pop-up screen that says device parameters are not ready. So this is a one-time first initial configuration of the H1 Pro. After doing this, you won't need to do this again, just only one time. So we choose the local import option and we choose next. And here you have two choices. First, the scanner parameters and calibration board parameters. You will need both of these files in order to properly work with your device, right? So we choose browse and we go to our PC and choose the USB flash drive. Here you can see 30 gigabyte USB flash drive, and we choose the device parameters place and choose this one. And now we need scanner parameters. Here, for the sake of demonstrating, we have 3 different parameters, and which one is the correct one? You will need to compare the SN number of your device to the 4 last digits of the configuration here. So I can see that the SN number of my device is, the 4 last digits are 0009. So I will be looking for the same numbers on my PC. So here you have 0034, that is not correct. We have 9982, that is also not correct. But for the sake of showing what will happen if you choose the wrong parameters, I will deliberately choose the wrong configuration to show you what the program will tell about it. So the second one, we need to choose the calibration board parameters. So we go back to device parameters and choose the calibration plane parameters. And here we have calibration parameters. So we need to take out our dedicated calibration board from our box. Beneath this foam, we have calibration board. Let me take it out. All right, here you go. Let me put it away. We don't need this anymore. So this will be our calibration board. In order to know the correct number of the calibration board, you need to look at the back side, and here you have the SN number of your calibration board. Here you can see that it shows 0011, the last 4 digits, and we will look for the same number here also. Here we have 0011, this is the correct file. Well, of course, when we send the USB flash drive, there will always be only one, the right correct file, so you won't even have to think about choosing the wrong one, right? So we have the up sign here on the backboard, on the USB calibration board. So you put it this way. We go and choose the correct one for calibration board and the incorrect one for scanner, and see what will the response of the program be. That we put here and choose OK. You can see that it notifies us about the incorrect parameters. Parameters cannot be used. Currently imported parameters do not match the device, right? So we go and return to manual import, and we choose the correct one and see what the program will say to us. 009 is the correct one. We choose it. We chose the correct one for calibration board also. Now we can safely choose OK button. And you can see that device parameters are ready. So this was the whole process of importing the initial parameters and the configuration files of H1 Pro to your PC. Now that we're ready to work, the next thing I want to talk about, of course, is the warm up and the stabilization of the 3D scanner. Before using the scanner right away after connecting to your PC, you will have to need to reach a certain degree Celsius of the 3D scanner. So to check this, you want to go to create a new project, and you will have to wait until the 3D scanner is warmed up. So the best way to do this would be to put the H1 Pro into work. So we'll have to scan the random object for our 3D scanner to reach a certain degree. Around 37 degrees would be enough to say that it is warmed up and ready to work, right? So usually before starting the scanning, we do the calibration, but not for this case because we want to make a warm-up. So we will use this car door here, car door, the back side of a car door. We will scan it without calibrating our 3D scanner for the purpose of warming up, right? So we create a new project and we jump into scanning. We won't even have to scan the marker source. We just scan the point cloud right away. So let's do it. So this way, after warm up, our machine can deliver the best performance and stable workflow. That's why we have to warm the H1 Pro up. And before we jump into real scanning, I want to remind you about our Kickstarter program that we successfully launched already. So if you haven't checked it, you can head out to our Kickstarter page and pledge $5 in order to lock the best price option for yourself and get the device with a huge discount. All right, so this was the warm-up. You can see even without warming up the device, we have already successfully, without any lags or any problems, we scan out the whole car door. Now, of course, we just needed to do this because we wanted to warm up our H1 Pro. So today, in this live session, we will only demonstrate the wireless mode because our H1 Pro can deliver the true wireless mode scanning, right? And here we have the uncalibrated scan, and you can see that it is already looks clean and usable. But we won't do this. We go back to our main page. Now I can say that the device is warmed up and ready to the real work. Okay, so first we will do the calibration. I want to talk about one point that no other 3D scanner on the market can do the calibration in a wireless mode. Only the H1 Pro, right? So even for the calibration, we don't need to use the cables to do the calibration. So this is one of the huge advantages of our 3D scanner. So we go to our calibrate option and just follow the instructions inside the program. This won't take too much time. This is really easy and simple. You just need to follow the instructions that are shown inside the program. It won't even take 30 seconds to finish the calibration of H1 Pro, and this would be the final step. Yes, the calculation is successful. Now we can jump into a real scanning. Create a new project and we can scan it. So I want to also talk about the next advantage of our 3D scanner, that we send our scanner including the phone mount and strap. So you can attach the strap to your hand, wrist, and attach your phone, your smartphone, directly to your wrist and see the scanning process. So use your smartphone as a real-time display to show to see the workflow of 3D scanning, right? Without having needed to look at the display of your laptop or any other screen. So we have a dedicated VoxMeta program app for your phone that you have to download and connect the Wi-Fi to the Wi-Fi of the 3D scanner and start scanning. So we'll demonstrate it a little later. For now, we can remove our USB flash drive. We finished with calibration. Now we can jump into scanning. So we have several interesting objects for you today to demonstrate. So I will take the laptop screen here, and we start by scanning the car door. We just scanned this without calibration. Now we're gonna do it with a calibration. So this way we can achieve the highest possible accuracy. So we start from markers. While we do the scanning of the markers, if you're new here and don't know the specs of our 3D scanner, I want to remind you that the H1 Pro equipped with a industrial grade camera with minimized noise. Also we have the aviation connector, the RG45, that is vibration irresistible and delivers best power supply to the 3D scanner. Here you can see aviation connection here that we will demonstrate a little later. And also we finish with scanning the markers. Now we can move on to scanning the object itself. Long press on the M button, double tap on M button, we switch on to parallel lines. Talking about the lines, we have 3 scanning modes. The one that I'm using right now is 34 crossline laser mode for fast and wide range scanning. Also we got 17 parallel lines for fine edges and surface texture, right? And we have the final one is the single laser mode, single blue laser mode, that is for deep holes and narrow slots. So each scanning mode has its own purpose. So according to your demands and the type of the object that you prepared to scan, you can switch between these 3 modes anytime you want during the scanning. So I can see that we've almost finished scanning the car door. I want to make sure to capture everything here. You can see that this object has a lot of surface structure, complex geometry, but that's not a problem for H1 Pro, because you also can notice the speed that the scanner is capturing the 3D mesh. It's 120 FPS frame rate, super ultra smooth with capturing power of 4.4 million points per second. That's best on the market, right? So we can finish the scanning with a long press on the play button and further process our 3D model. The point cloud optimization is rapid and fast due to the fact that we have built-in AI chip that is quite powerful to process any 3D model. You can see that I missed some spot here. You can resume scanning anytime when you notice some places you didn't capture correctly. Here you can see I can save the day by scanning again, by resuming. Now that I made sure I captured everything, I can move on to processing it. So long press on the play button again, and we can further process our mesh model. The cloud optimization is very quick. You can see all right, so we move on to cleaning our SDL model. You can see a lot of unnecessary parts that are also being scanned. So we choose this associated point cloud option. We choose our main body and we do the inverted choice. This way we can delete all the unnecessary parts, but we can leave this one. Oh yeah, so we can delete the rest, and now we're left with a pure STL model. We go to meshing, and using the general mode from several options, we apply and create STL mesh that you can export out from VoxMeta program as an STL mesh and import it into CAD modeling programs for further processing, whether it's research development, reverse engineering, quality inspection, etc. Right? So the meshing is being conducted. While it is going on, I want to talk about the main advantage of H1 Pro. That's the precision value. The H1 Pro delivers the basic precision of 0.050 millimeters. For larger objects, the volumetric accuracy will be 0.050 millimeters plus 0.03 millimeters per meter. And if you use our fiber scale bar, you can achieve the volumetric accuracy of 0.050 millimeters plus 0.02 millimeters per meter. That is a staggering value. So now the meshing is complete. Now you can check out the final result. You can see the holes, the curves, all the texture on the surface. Everything is captured very precisely, and this is, we can say it is a very solid scan. Now let me switch into solid plus wireframe. You can see, check it for yourself. So what do you guys think about this one? Leave in the chat your opinion. The feedback is really important for us. Now that we're done with scanning the car door, we can move on to our next task. So we have here several interesting models here to scan, and for now we will start one by one scanning all of them. So I want to move my PC to a better position so that I can see everything. Okay, this way. So you can notice that I'm using wireless mode, and it is extremely convenient because you're not tied to your PC or any other device while working. So I don't have to worry about getting tangled by the heavy, thick cables. I have total freedom of movement. And due to the fact that we have Wi-Fi 6 and Bluetooth connection, a gigabit wireless transmission, you can see that the connection is extremely stable. There is no lags or any other type of problem with connection. For now, I will move them aside, and we are left with this big boy. This is a die-cast automotive aluminum structure that is quite big. It is almost exceeding 2 meters by length, and the width is also exceeding almost 2 meters. This is a huge and very hard task for any 3D scanner on the market, and today we're gonna be using the wireless mode to scan out this one. For large die-cast components like this, not all areas require the same level of detail or dimensional accuracy, right? In today's demonstration, we'll use a lower resolution in order to capture the full geometry of the part while applying higher resolution scan to critical areas, critical parts like this, features, to critical features and inspection areas. By combining these data sets, we can achieve both efficiency and required measurement accuracy across the entire component. If you didn't get what I said just now, you just can stick with us. I will show you step by step what I mean by that. So now we start from scanning the whole body using lower resolution to scan. So we create a new project here. We go to our main page, create a new project. Here in a point spacing, we'll choose a lower resolution. There would be 0.8, and for shutter we choose 0.5. And first we start from scanning the markers on the object. This one is quite a challenge for any 3D scanner on the market due to the fact that it has a lot of complex geometry on its surface, all these ribs and deep pockets. You can see there are deep pockets here that is extremely hard to capture for any device. So this is a very good choice of objects to demonstrate the actual power of the 3D scanners. In this case, the H1 Pro, our new flagship industrial grade 3D scanner. It will take a certain amount of time. It is required to use a longer time to wholly capture all the details on this one. It will consume a longer time than usual, but that is okay. You can see the 120 FPS frame rate shows itself in such tasks. So we finished with scanning the markers. Now, before we move on to scanning the object itself, I can see many of you are asking in the chats in the previous live sessions about the specs of our PC, what kind of specs you need to achieve 120 FPS frame rate. So let's talk about the specs a little bit. So minimum requirement specs would be Core i5 12th generation paired with RTX 2060 or Ryzen 7, right? This is a minimum requirement, and the recommended requirement would be for your PC is Core i7 Ultra 7 with 155H HX plus RTX 4060, right? And now I want to show you the specs of my PC. Here we go here, and you can see the CPU. We have Intel Core i9 4900HX that has 24 cores. It is a quite powerful CPU. We have RAM, 64 gigabytes RAM. You can see, of course, SSD. Any modern PC has SSD. Also, and the most important part is the GPU. We have NVIDIA RTX 5070 laptop GPU. So this was the specs of my PC. Now that we talked about this one, we can move on to scanning the object. So let's do it. Again, we'll use 34 crossline laser mode in order to quickly capture everything on the surface. This object is particularly a big challenge due to the fact that it has a lot of blind spots like this. You can see, even though I thought that I scanned it completely, I still missed some spots. So you will have to scan it from different angles in order to not miss any spot on it. All the surface curves and hidden spots, it is a really task for any 3D scanner to capture it correctly. You can see that my PC specs is enough to achieve the promised 120 FPS frame rate. And here we have a very complex spot, the deep pocket. You can see now for this one we can use the single laser mode, the dedicated single laser mode. A little later I will demonstrate to you how we can successfully capture such complex areas like deep pockets. This is where the single laser mode shows its true power. All right, we're almost done with this part. And of course you want to keep a moderate distance between the object and the 3D scanner. Otherwise you will have a pop-up screen on your VoxMeta program saying they will notify you about the fact that you need to keep the distance between scanner and the object. Now we're finished with this one. Alright, from this angle I don't want to miss any spots, so I want to make sure that I capture everything on it. Overall, the scanning process is really enjoyable due to the fact that we are running at very high speed at 120 FPS. There is really a honey to your eyes. Just look at the building up of 3D model in real time. So we have this place that we captured successfully. Also this one. This place is a very complex. It requires a quite amount of time to capture it from different angles you can see. So little later we'll use a higher resolution to capture particularly this place. This is the lower part. And also it has a surface texture that is needed to be captured. All right. Now I'm positive that I captured everything on here. The scanning process is really enjoyable. We are capturing 4.4, staggering 4.4 million points per second. And this spot is easier due to the fact that it doesn't contain any blind spots or complex, difficult geometry. So you won't take too much time to scan this part. But the left side has a lot of blind spots. We'll have to spend some time to scan it all. But you can see the beauty of 34 cross-line laser mode. There is very rapid, and it can cover a wide range of area, scanning area. All right, for this one. And here you go. Almost there, guys. All right. So we pretty much captured everything on here. Now, for the sake of demonstrating, I want to show you the power of single laser mode. Let's switch to the single laser mode and capture this deep pocket. You can see that even 34 cross-line laser managed to capture this one, but we still have some. You can see that it is capturing the deep pocket. And also check out here. And try to capture this spot. All right. As you can see, we're capturing everything that we missed using the 34 cross-line laser. The powerful concentrated single laser mode is what we needed in order to scan these blind spots. All right, also this one. So let's come and try to scan this part. All right, pretty much that's it. Now that we finished with this one, we can move on to processing it. And as I said before, we will have to scan a complex area once again, long press on a play button, and now it's finished. We'll have to wait a little bit while the point cloud optimization is being conducted. Even though it's a huge object, the built-in AI powerful chip can manage to quickly process the whole object. As you can see, it didn't take us even 1 minute to complete. So now I can see that I have some spots I missed to scan, so I can resume on scanning by pressing. All right, this way. Here you go. Nice. Now that we're done, we long press it and we will scan this area once again. Create a new project within the project, so later we can align them together. All right, this one, let's first clean it up. Okay, let's remove the plane, so we left with the pure 3D model itself. We choose the associated point clouding, inverted choice, and delete it. Now we can create a new project. We change the point spacing up down to 0.50. This is a higher resolution, and scan out this complex area. Let's do it. All right, now currently we're using 34 crossline laser mode. We can pause and switch to single laser mode. And we can zoom in so you can see everything much clearer. So you can see we're trying to capture everything from all angles possible. Almost there. Also from this side. Okay. Move to cross lines. It is a little time-consuming task, but that's okay because we want to have a nice results of scanning, right? So we finish with this one. We long press on finish and move on to alignment, right? So the point cloud optimization is being conducted. I'm sure it won't take too much time. All right, now you can see how nicely we captured this one. So we close it, we open our previous project. As you can see, Here we have a lasso option. We choose and we delete this part. After deleting this part, we go to stitching and we choose the auto stitching. And here you go. Here is the result. As you can see, we choose the second scanned file to replace the first one for this particular spot. Apply. And see when the applying is complete. Now you can see the difference between these two. This is the replaced one. You can even see the texture on it. Now we've been almost live streaming for 40 minutes around, and we've been using the H1 Pro around for like 25 minutes. And let's see how much power we have left with our 2 batteries on the H1 Pro. In order to check this, you can see here is the percentage, battery percentage that is shown that we used 20%, just 20% of the battery percentage, and we left with 80% left. So we've been scanning for 20 minutes. That means the batteries are very stable. They are engineered for long-term working hours. So you can, if the battery is depleted, you can remove it and still not turn off the device because it is hot swappable batteries, which means that you can non-stop work with the 3D scanner. Even though if you remove one battery, you're left with the other one, so scanner is not turned off. Also, we have lithium battery charger within the box of H1 Pro that you can use in order to charge the batteries of the scanner. I can see that meshing is almost complete. So this is a big project, a big object, and here is the final result, guys. Let's check out. Just look at this. All the geometry, all the details are very precise, and here you can compare these 2 objects, 2 details. You can see that this one is very visible. So this is a good method if you want to capture some details very precisely and accurately, and some details you don't need that level of accuracy. So you can use 2 different point spacing in order to achieve these results, right? And also you have the texture here. You can see the texture on the surface that was successfully captured. All these ribs and curves along the body, everything is. Let's choose the wireframe and see everything for yourself. So what do you guys think about this one? Leave your opinion in a chat. and we are moving on to the next object. So now the next object would be aluminum part. So we'll try to, this is a quite reflective object. We'll try to scan it out. So we create this file, we save this file project inside the program locally. All right, let's go back to the main page and create a new project. We successfully saved this project and create a new project. Point spacing is back to 0.50. We don't need that level of precision, and to shutter to 0.5. Let's scan the markers on it first. This is a quite reflective object. Let's scan let me zoom out so we can see the whole object. Now that we scanned it, long press on a play button. And I recommend to remove the plane before starting the scanning. So you can see the program automatically identifies the plane, and we apply. And now we can double tap on the M button and choose the cross-line laser mode to scan the whole object. Let me zoom in so you can see the capturing in details. Closer picture. By the way, while we're scanning, I want to ask you guys to write down from where you're watching us. What is the timeline right now in your country? We're very curious about our audience. Where exactly are you from? How did you find us? How did you learn about our new project? That is very important for us. You can see that it just took me 20 seconds to completely scan out this whole object. Now we can move on to processing it. All right, here we have a clean data. We go to meshing, we choose closer to reality option first and see the results. Here you have a closer to reality option. You can see how accurately everything is captured. You can compare it to the 3D STL mesh. This was the closer to reality meshing option. Now we can go back to our point cloud and choose the smoother option and see the difference between them. And you can see the surface became much more cleaner and more smoother. You can see how accurate every detail is. All these bulks, all these dents and curves. Everything is very precise and accurate. Now let's save the file and move on to the next one. For this one, we'll use the turntable. We have a dedicated turntable within our box. So beneath all this foam, you have a turntable, manual turntable. We'll use it.打开一下文件。把文件打开一下。I will create a new project. Okay, for this project we will use the same tactic as we used for this one. We will use a lower resolution in order to capture the whole body, and we will use a higher resolution in order to capture critical and demanding parts such as this one, and align them together to get the best possible result. So this is a black and highly reflective object, so we will choose a dark mode, but first we need to scan the markers on it. All right, we finished. Once again, we remove the plane on it first. Okay. Double tap, and we can start scanning. I think I forgot to adjust the exposure. Now we set it to 05. For this type of projects, you need to scan it from different angles, because this is a highly reflective object. So you want to keep the scanner in a distance, and you can check the indicator on the left side of your program. The green light means, green area means this is the means that the scanning distance is very moderate, and the red one means that you are too close to the object. All right, now that we finished it, we will long press on play button. I can see that I missed some spots, so I have to resume the scanning in order to save it, in order to capture it more precisely. All right. Now that we're finished with the scanning, we can move on to, you see here, this area we need to scan using a higher resolution, so we create a new project. We set it to 0.20. And start scanning. Let me zoom in so we can see everything.把文件打开一下。All right, we're almost there. You want to make sure you scan it from all angles, like this one. Alright, here is when the single laser mode is extremely handy. It can capture the critical areas with the highest precision and accuracy. Now that we finished scanning, okay, long press finish button, and we go to processing it. Let's close this one and open this one, and again the same tactic we used with a die-cast project. We delete this part. We choose the stitching, and here you go. Here you go. This way we can achieve a higher precision for more demanding parts. As you can see, this bulk on here, even this minor detail have been captured very accurately. So we can delete this one, stitching into stitching. Okay, apply. Now we go to那个把它关一下。那个文件关一下，关掉，关掉！哇，这天呐！喂 Now you can see the meshed file. Here we have this detail on it. All it looks very solid. So what do you think about this one? You can leave in the chat. opinion, we move on to the next project. For this one, I want to save it to my local project. And we go back to our main page and create new project. So the last one would be the World Cup. We have World Cup for you guys here. 这个参数是谁记的？不用展示，看你自己说一下就好了。自己说一下就好了。上面去。哦，音慢，可以关掉，可以关掉。Alright, so we have this World Cup that we want to try to scan out. We use 45 point spacing and we scan the markers on it first.
We are doing some live streaming, so maybe you guys can go here. And this is our new product. Handle is here. Maybe you guys can wait till I will ask my colleague to bring one handle scanner. Then you guys can
We create a new project. We start from markers. Create the scanners on it first. All right.
This is one case of laser product. You need to use some other parts. That's why
Okay, I recommend to you to remove the plane first before scanning it. So we choose the inverted choice and apply. Now we can move on to scanning it. Not the single laser mode, we need the cross line. All right, by the way, the World Cup is going on right now. Who do you guys root for? What is your favorite team? You can write it in the chat. I personally root for the Portugal because Cristiano is my favorite player. So to celebrate this event, we're scanning a World Cup. All right, now we can zoom in. All right, we're finished here. Now let's check the results. And here you go. So this is a scanned World Cup. This is how it looks like. So what do you guys think about this one? So this was the World Cup, and now we can move on to the next project. Next one is a B column. It's a quite long and big object. We try to scan it here. Oh shit, it's quite heavy. We create a new project. We go back to our main page. Set the point spacing up to 0.50 and scan the markers on it first. Now that we finished scanning the markers, we can remove the plane on it. Actually, we don't even need to remove the plane. Let's just jump into scanning. This is where the 120 FPS frame rate shows itself. It is very quick, the fast mode. All right. You don't even need 1 minute to scan the whole body. I run it one more time to make sure that everything is captured precisely. And now we can long press. Here you go. Let's clean it up. Okay, first we go to removing the plane. Okay, we can directly mesh it up and see the results. The meshing is almost complete. Let's check the result. It also has a lot of interesting geometry on the surface. You can see that every detail was captured very precise. So here you can see it for yourself. So what is your opinion? Leave it in the comment section below or in the chat. All right. So where's the oil pan? Oil pan. 油箱地壳. No oil pan. Okay. So this was the last. Yeah. So the last part would be the wired mode. So far we've been using the wireless mode for scanning. Now we can move on to wired mode for this one. So this is the power adapter for our scanner. And in the box we have aviation connector RJ45 for stable power, RJ45, and we have Ethernet cable here. So right now we're gonna use a wired mode and show you how it performs. So we have the power adapter here. We connect it to the power. This one is used to connect to the PC. So you have to turn off the device first. All right, now that we turn it off, we connect the adapter to the PC. Let me put it here for convenience. And now we can connect our RJ45 here. It is a vibration resistible, a very solid connection. Right now we are using a wired mode, so we wait until the program identifies our scanner and we can move on to scanning the object. All right, you can see the program sees our scanner and we create a new project, scan the markers on it. So this will be our wired mode. All right, now double tap on the M button, we can start creating. Once again, I want to remind you guys about our Kickstarter program that we launched. So you can put your orders there. Also, you can check our official website, VoxMeta.com. And you can subscribe to our Facebook group, VoxMeta group. Also, if you're not subscribed to our YouTube channel, please feel free to subscribe to it, because we have a lot of new upcoming interesting projects for you guys. So we finished scanning. We long press on the play button and see the final result. So this is it. Now I can see that I missed some spots here. It is very convenient that I can scan it anytime I want. Once I notice some incorrectness, I can fill it anytime. All right, so this is it. Let me clean it up. Inverted choice, we delete this one. Now we go to meshing, closer to reality, and apply. So pretty much this was all today. We demonstrated to you the performance of H1 Pro in a wireless mode. Also, the last scanning was in a wired mode. I hope you guys have a pretty solid idea about our new project. What does it represent? What it is designed and engineered for? So you can compare it to other scanners on the market and see the difference between them. I'm pretty sure you're gonna notice and you will discover a lot of advantages of H1 Pro in comparison with other 3D scanners on the market. So this is the final mesh model we have here. You can see all this surface texture, these curves, these edges, everything is captured very precisely and accurately. So I'm 100% satisfied with the result. What do you guys think? Leave your opinion in the chat. We'll be happy to read your remarks, your suggestions for our next upcoming live session. What do you guys think us to show you about our new project H1 Pro in the next live sessions? So this was pretty much today. Thank you for attending. We will be waiting for your attendance for the next upcoming live sessions, and see you in the next videos.
For the kind of inspection work we do, consumer scanners just aren't accurate enough, and metrology equipment is usually out of budget.
With large part scans, things can get messy fast. The alignment's off, and that kind of delay can cost you the customer.
Traditional measurements already takes too long, and some scans just don't stay true to the real part.
And that's where things start to change. VoxMeta has spent over 10 years in industrial scanning. We know what precision means when real work depends on it. So we built H1 Pro, an all-scenario 3D scanner grounded in industrial-grade precision. Made for real users and real workflows. Built for precision and you.
I work with molds almost every day, so accuracy is really, really important. If the scan data isn't stable, we end up checking the same part again and again. And once rework starts showing up, it slows down everything after that. But with the H1 Pro, the part of this job just got a lot easier. I can scan the whole mold, see the data bill right away, and move straight into comparison. What I like about the H1 Pro is that it brings industrial metrology level precision into something we can usually use every day. You're getting up to 0.015 millimeter accuracy, plus 0.015 millimeters and 0.03 millimeters per meter volumetric accuracy. And the data stays stable.
An aerospace-grade aluminum body keeps H1 Pro rigid and stable. An industrial-grade camera system delivers clear, low-noise imaging with consistent precision. Industrial aviation connectors, gigabit Ethernet transmission, Wi-Fi, and Bluetooth work together to keep every connection secure and transfer stable. Because in inspection, everything starts with data you can trust.
It's not complicated to use, and the pricing is much more reasonable for a team like ours. We can scan the whole mold, we can compare it fast, and we can move into inspection without all the usual issues. This means faster spot checks, it means less rework, no more staying late, and a smoother handoff across the whole team. It saves time and it saves money, and it keeps the line moving. And honestly, it's just really, really practical.
At the shop, we scan large parts all the time. Bumpers, lips, side skirts, and even the full section of a car. And once the cable gets in the way or loop closure error, the whole job just gets messy fast. You lose time readjusting the equipment and scanning again. In this business, that can cost you the customer. Once I started using H1 Pro, the whole thing just felt a lot more under control, especially on larger jobs. It's a wireless handheld scanner, so I'm not dealing with cables all the time, and I'm not worrying about the battery life either.
With 120 frames per second and up to 4,400,000 points per second, the whole scanning process feels a lot faster.
Honestly, it's probably twice as efficient for the kind of work we do. And with scale bars, we can now scan large parts up to 5 cubic meters, with the volumetric accuracy now up to 0.015 millimeters and 0.02 millimeters per meter. So even the alignment stays precise even on bigger jobs. And that means one device handles most of the automotive customization work we do here without all the extra spending. So we spend a lot less time on measurement and test fitting now. And honestly, it just makes everything easier and more efficient.
When I'm working on custom modifications, reproducing old parts, precision and efficiency are always the hardest part. With consumer-grade scanners, the data often isn't accurate enough, and sometimes the scan gets cleaned up automatically. It looks better, but is no longer true to the part. But with the H1 Pro, I can finally capture the part the way it really is. Thanks to the versatility of blue laser, it handles different materials really well, which matters a lot in my work. What I like most is how true the scan stays to the real object. It doesn't try to smooth things over or improve the result. It just stays faithful to the part. So I'm not wasting time reworking the scan or second-guessing the data. And honestly, that just makes the whole process feel a lot more solid.
Different workflows lead to the same core, steady metrology-level accuracy with fully accountable measurement data. That's the thinking behind H1 Pro, and it's how VoxMeta approaches every tool we build. VoxMeta H1 Pro metrology-grade 3D scanner. True specs meet true value.
For the kind of inspection work we do, consumer scanners just aren't accurate enough, and metrology equipment is usually out of budget.
With large part scans, things can get messy fast. If the alignment's off, and that kind of delay can cost you the customer.
Traditional measurements already takes too long, and some scans just don't stay true to the real part.
And that's where things start to change. VoxMeta has spent over 10 years in industrial scanning. We know what precision means when real work depends on